Hi guys, this is Dr. Gonzalez here, and in this video we're going to talk about how you would go about identifying good measures, especially how it applies to experimental research design. So without further ado, let's get into it. So turning your variables into constructs that are conceptual to operational is easy when we talk about it. But it gets a little more complicated when we bring that into the real world. How do you measure or manipulate variables that exist in the abstract? So if you look over in the table that I have here, there are some examples of variables and their operational definitions. So if we look at religiosity, one possible way of operationally defining that is by asking people if they agree with the statement, "My religious faith is the most important influence in my life." But next to it, I have another possible operational definition, asking people how frequently they attend religious services. Those are both attempting to answer something about religiosity, but one is a subjective measure that is very much about your agreeing with a statement, and the other one is asking you about something that I can quantify and count. So how do we go about doing this? There are a lot of different measures that exist out there, and whether you're doing an experiment or not, you're going to need to take these different types of measures into consideration. So when we use self-report measures, you're recording people's answers to questions about themselves, and it could be through a questionnaire or an interview. We might ask questions like, how many caffeinated beverages have you consumed today? When's your bedtime? How often do you take Zolpidem for sleep? That's Ambien. How frequently do you get up in the night to go to the bathroom? Those are all things that are self-reported measures. We also have what we call observational or behavioral measures, and these are behaviors or traces of behaviors that we can count how often something is happening. Your allergies could be operationalized by how often you sneeze. A behavioral task like your working memory could be assessed through a digit span task. Or I could just record how long you're sleeping to get at duration of sleep. Physiological measures are things that are recorded using biological data. And they might include things like an EEG to record your brain behavior during sleep, maybe how fast your heart's beating before a test, or your cortisol levels measured through some sort of blood test. These are biological things. This gets at the question, which kind of operationalization, I can never say that word right, is best? There is no single best way to operationalize a variable, and no one way is going to necessarily be better than another. So it's best if your three types of measures show similar patterns of results, or you're going to have to spend more work to try to figure out what exactly is going on there. So whatever you end up choosing, you need to make sure that it's a valid and reliable measure for the variable that you're trying to get at. So let's review scales of measurement. This should have been something that you've gone over either in 4370 or in your introductory statistics classes. We have categorical versus quantitative variables. Categorical are considered qualitative. They're nominal groups. They're simply categories. This might include something like eye color or your sex, biologically speaking. And they are going to be things that have to be coded in a special way because they're qualitative. These are flexible and they focus on retaining rich meaning from the answers that are given. And you can interpret them with certain qualitative coding and analyses, and you get things called narrative themes, or you might do a case study. Those are qualitative measures that are covered in the other course, so we're just going to mention them here and kind of move on. But your other group is going to be your quantitative variables, and these are going to include all of the different things that I can quantify and code with a meaningful number, like heart rate or scores on a depression inventory. Under those quantitative variables, we have three different levels. You have ordinal, which is simply ranked order. So this would be like first, second, and third in a race. So I can tell you who was first, who was second, and who was third, but I can't tell you the distance between first and second and third, and it may not be equal. interval is when we have numbers that represent equal distances between those levels, but there's no true zero. An example would be IQ scores. So we tend to not, this is something that doesn't have a nothing, a zero to it, because it doesn't mean it means no intelligence, and that doesn't exist there. The temperature would be another example of that, body temperature. So maybe I measure that in conjunction with some other physiological measure to get at, I don't know, anxiety. And I would hope I don't find anybody who has no temperature, because they'd probably be dead. Ratio is when our numbers represent equal intervals and there is a true zero. So exam scores. It is quite possible for you to make a zero on an exam. So that would be an example of a ratio measurement. This is just summarizing. The categorical or qualitative measurements are nominal, and that's it. And your quantitative are ordinal, interval, and ratio. Now, in another video, I talked about validity, and we're going to touch on a couple of points with validity in this presentation again, but we're mainly going to focus on reliability. So what is reliability? Reliability is consistency amongst scores, depending on what subtype of reliability I'm looking for. So I have 3 on this particular screen right now. Test, retest reliability means that I'm giving a measure that provides consistent scores every time I use that measure. So for example, the PSYC, the Pittsburgh Sleep Quality Index, measures sleep quality using several different subscores, and it's a valid and reliable measure of sleep quality. I know that because it has gone through multiple test, retest situations, and we know that it provides consistent scores when it's used. Now, when we're dealing with observational data, we're going to need to check on our inter-rater reliability. And this is when you have 2 people that are rating a behavior or observing something, and they're going to rate whatever it is they're looking at consistently. Okay? If I'm counting the number of times a student disrupts a teacher during a 1-hour lecture, I want Matt and Mark to both report the same number of interruptions. Otherwise, they do not have a high level of inter-rater reliability. Now, internal reliability talks about your participant providing a consistent pattern of responses regardless of how you have phrased the question. So I might ask a question, do you like pickles? And then later on, I might ask you the question, do you hate pickles? And I want to see the opposite answers for that, because that's going to give me a consistent pattern of your responses when I'm dealing with a variable that is liking pickles. Now, this is kind of a crazy thing, but it was the first one I could come to mind with, so I apologize. Now, in reliability, we often use a correlation coefficient, Pearson's R, of -1 to +1, and examine the slope and direction of that relationship. It can be positive or it can be negative, and that slope is dependent on the amount of variance, and that tells me the strength of the relationship. So on the right there, you have 4 scatter plots, and the one that is going to have the most is going to be this one right here. It's going to have an R that is almost 1. It's 0.93. You can see we have 0.56 here, -0.59. I do see a trend downward in that one. And then over here I have R equals 0.01, which is almost nothing of a correlation. So we use that when we're determining reliability of test-retest and inter-rater reliability, and then also we can use it for our internal questions on a measure to see if they're measuring the same thing. Now, how do we go about determining this? Like we just said earlier, test-retest reliability means the same participants are going to give their answers at least twice, and we're going to compute that Pearson's R. If it's strong and positive, then you can be assured that you've got good test-retest reliability. Inter-rater reliability, I'm going to use the same thing. I'm going to use Pearson's R, and I'm going to have a correlation between those 2 observations or those 2 observers, depending on how I look at it. And that's going to indicate good inter-rater reliability. And if I'm dealing with a categorical value, I'm going to use something called the kappa statistic to deal with that. I just wanted to mention that for you. Now, internal reliability is relevant for measures that use one or more items to tap into and measure the same construct. So that set of items is going to have high internal reliability if the items correlate strongly to one another. So in that case, you're going to average across those items and get a single overall score for each participant. And we measure internal reliability between those measures by you looking at Cronbach's alpha. That's a statistic that's frequently used to determine internal reliability. Now, validity of a measure means that it is measuring what it is supposed to measure. And underneath validity of measurement, we have face validity, content validity, criterion validity, convergent, and discriminant validity. You can look in your textbook and find this chart here. It's going to break down some of these different things that we've just talked about. Right now, we're talking about our construct validity, and we're looking at some different ways that we can measure that. Face validity means that it looks like what you want to measure, and this is seemingly subjective, right? So we often bring in experts that might examine face validity. They are very well versed in their field, and they can tell you if the operationalization that you've chosen is plausible for your particular construct. Now, head circumference, high face validity for hat size. So in other words, if I measure how big your head is around, that is going to correlate high with the size of hat you're going to wear. But it's going to have low face validity for the evaluation of intelligence because there's no correlation between head size and intelligence in adults. Now, content validity is going to measure whether or not you're getting at all of the parts of your theory that you claim you should be measuring. So there's an intelligence example on this slide, but I'm going to go again with the PSYC, the Pittsburgh Sleep Quality Index. So if I'm measuring sleep quality, I want to make sure I include as many domains as I can about sleep. I might look at sleep duration, how long you sleep during the night. I might look at sleep latency, how long it takes you to fall asleep. I might look at your subjective measurement of your quality of sleep. I might come out and ask you, on a scale of 1 to 10, how well do you sleep every night? I put those all together and I get content validity because I've covered not just one aspect of sleep. I've covered many aspects of sleep, and those things have been validated on the PSYC, so I know it has content validity. That's an advantage of using a validated measure in your research instead of making up your own. Now, criterion validity is your measure is correlated with a relevant outcome. So your SAT score may be correlated with your GPA, and your GRE score may be correlated with your outcomes post-graduate school. I say maybe because there's some doubt out there about whether those things are. But I can probably give you a better example of this. We give pre-tests or practice tests in the high school setting for end-of-course state-tested subjects, like I teach biology, for example. And if I give a practice assessment to my students, and that practice assessment is correlated with them passing the state test, then I know that I've got criterion validity for the things that I'm asking for on that practice test. Now, convergent validity means your measure is more strongly associated with other measures that attempt to get at a similar construct. And it's going to be less associated with dissimilar constructs. And that would measure discriminant validity. So measures of self-esteem are going to correlate positively with measures of self-concept. That makes sense, because if you're rating yourself high on self-esteem, you're probably going to rate yourself high on other measures of self. But measures of self-esteem shouldn't correlate with creativity measures. And let's go to an extreme one here. Measures of self-esteem probably shouldn't correlate with your sleep quality. Just going to go out on a limb there. So you've got convergent validity and discriminant. You can see here convergent means things are coming together. Discriminant, they are not correlated with one another. Now, I know there was a separate video about validity that we covered, especially with validity related to experiments. This one covered specific validity when it comes to measures. So I want you to keep in mind that validity and reliability build off of one another. Reliability is consistency of measures. Validity is I'm measuring what I want to measure. So you need reliability. It says reliability is necessary but not sufficient for validity. So I've got to have reliability to be valid, but it's not everything I need. And you absolutely cannot be valid and then be unreliable. So look at the 4 bullseyes down here. In the first one, I have reliable but not valid. So say I have a question that I'm asking to my participants. They are all giving me answers that are reliable. They are all in the same area of responses. But that measure particular item is not getting at the construct that I'm attempting to measure. So it's not hitting the bullseye there. Over in this middle one here, I have valid and not reliable. Everything is all over the place. Nothing is getting at the bullseye in the center, and nothing is reliable because it's not grouping in the same place. Now, I can also have something that is neither reliable nor valid in the middle on the right because I have things that are just kind of in the half upper part of the bullseye. So again, it's not quite enough for me to call it reliable, and it's not valid because only one score is in the middle. On the right, I have the ideal. I have a bullseye that shows a grouping around the center. That shows me that I am getting at what I'm trying to measure. And over time, those scores are hitting at the same thing every time I measure it. So I know that was a very brief video. There are several across this particular week. I know you've got a lot of assignments to work on as well. Please check Canvas for instructions, videos, and templates related to this week's assignments. Reach out if you have any questions, and I look forward to talking to you again in another video. Take care.